Dear student, we are on the CEC Gurukul lecture. We are in the series of experimental physics where we are discussing some of the optics experiments. In today's lecture, we are discussing the polarimeter experiment. The aim of the experiment is to find out the specific rotation of the sugar solution by using the Lorentz half-shade polarimeter. Then what is this Lorentz half-shade polarimeter? Then what is this Lorentz half-shade? Lorentz half-shade consists of the semicircular half-wave plate. On the diagram we are having that is circular plate. This plate, just you are seeing that one side we are having a lines and another side we are having the plane. So half-wave plate made of a quartz and the glass. So then it consists of the semicircular half-wave plate ABC of quartz that cut parallel to the optic axis. The ABC, the quartz is cut as parallel optic axis so that it introduces a phase change between the extraordinary and ordinary ray passing through it with the amount pi. And the semicircular glass plate is also attached with it as you see in the diagram ADC. So this Lorentz half-shade polarimeter made of one half quartz and half glass. Half part ABC made of the quartz and ADC we are having the glass. So the quartz which we are using in such a form that we are getting the phase change of pi or path change of lambda by 2 in between the extraordinary and the ordinary ray. As we all know that when the light passes from the quartz tube, then it split into the two parts. One is ordinary light and another is the extraordinary light. Then extraordinary light and ordinary light move with the different velocities. The path change in these two rays must be of the pi, so that we can find out the angle of rotation. So here on the screen we are having that this side we are having a PQ light pass through this quartz tube, then emergent out light is RS. How much angle the light is rotated at this much angle. So right hand side we are seeing here OM x axis and y dash for the y axis. The light rotate with an angle pi. So the thickness of the glass plate we kept in such a manner so that it absorbs the same amount of the light as the quartz plate. Quartz plate there is a change in the pi, so we choose the glass plate in such a manner so that we can find out the same output. Let the plane of vibration of the plane polarized is incident normally on the half shade devices along the PQ and then making an angle with the AC. Here see that we at AC we are having an angle theta. AC is the middle line which split the quartz plate as well as the glass plate. The light pass from the direction PQ then particular angle theta. The vibrations emerge from the glass plate part of the half shade device as such that there is no change along the plane PQ. When the light passes from the glass plate, then there will be no change. But when it is passed from the quartz part, then there is a change of pi. Inside the quartz plate, which is doubly reflecting, the light is divided into two components. One is the ordinary and another is the extraordinary component parallel to the optical axis. The two components then travel along in the same direction through separation but with the different velocities. The ordinary component moves greater than the extraordinary component. It means the ordinary component having the greater velocity as compared to the extraordinary component. On emergence, a phase difference of pi is introduced between them, or the path difference of lambda by 2. Due to this phase difference, the direction of ordinary components get reversed. So we can get that the PQ, here we are saying that this PQ just shifted to the OR, OP shifted to the OR because of the phase difference of pi. So due to this phase difference, the direction of ordinary component get reversed. If the initial position of the ordinary component is presented by the OM, then the final will be ON. Now on emergence, the resultant of the ordinary OL and the ordinary component ON will be OR, making an angle theta with the y axis. Here we see that ON just converted into the OM, converted into the ON, here OP into the OR. So at the vibrations of the beam emerge out of the quartz portion of the half shade devices will be along RS. This is the change from PQ to RS. Here we see in the diagram incident light along the PQ, the emergent light along the RS. So there is a change in the direction. That is because of this half shade polarimeter, which just create a phase change of pi between the path of the ordinary and extraordinary ray, and part difference of lambda by 2 and phase difference of pi. So this output is we can get the essential part of this polarimeter are monochromatic light source, convex lens which changes the incident light into the parallel one, a polarizer which makes the light plane polarized, then Lorentz half shade tube containing the optically active substance. After that, after passing from this Lorentz half shade, it pass from the optically active substances. The light emerge from this optically active substances tube, then pass through the analyzer. This analyzer have a capable to find out the rotation about the common axis. The rotation of the analyzer can be read on the circular scale which is attached with the analyzer. Analyzer is movable, but the polarizer is fixed. The light after passing through the analyzer is viewed through the telescope which is focused on the half shade devices. If it pass the direction of the analyzing polarizer which is capable of being rotated, and we fit it on the circular scale, and in this manner we can find out the output. Hence the field of view in the two halves will be equally bright because of the half shade devices serves the purpose of dividing the field into two halves. A little change direction, past direction of the analyzer make the one half brighter and another half darker. In the experiment, tube is filled with the water first. Then we focus the telescope and we light pass from the we rotate the analyzer. The two halves are equally bright. The position is noted on the circular scale. Now the tube is then filled with the optically active solution and then again placed at a particular position. In the previous position, the analyzer is rotated, then we brought a position such that the two halves are equally bright again. Either we can take the darker point, we can take the brighter point. We usually take the brighter. Here see the light source passed from the in between that there is a polarized filter or the quartz tube, then our sample tube where we are having the solution, then the analyzer we will put, output we are getting. In the first instance we put the water, in the second we put the sugar solution. This new position is noted and the difference between the two regions gives the angle of rotation accurately with the sugar solution and without the sugar solution. What is the procedure to perform this experiment? First we make the sugar solution. Then first we weight the sugar crystals in a watch glass and dissolve it in the 100 cc distilled water. Then we calculate the concentration of the substance. For example, if we are taking the 40 gram of the cane sugar that is dissolved into the water of 100, then the concentration will be 0.40 gram per cc. After that, we clean the glass tube from both the side and first fixed it with the distilled water, and it should be free from the dust and bubbles. No bubbles inside the tube. Now we put the tube in the frame and switch on the sodium light, and we note the reading through the analyzer which have the eyepiece, and we rotate the scale. Then we note the reading. As we see the two equal portions of the dark and bright that can be interchanged after rotating the analyzer. Now rotate the analyzer first in the clockwise direction, then in the anti-clock direction. We have to rotate the circular field of the view becomes bright. We are taking the brighter reading. Then we note down the reading. After that, we can take the second and third reading for both the direction in the absence of the sugar solution. And we take the mean of two direction readings separately. Now take the polarimeter tube and fill it with the sugar solution with the particular concentration, and put it in the same frame and fix it properly. After that, we repeat the same process. We put, and then we find out the reading through the analyzer in the clockwise as well as in the anti-clockwise direction. Similarly for the other set of readings also. The difference between the water and sugar solution readings gives the value of specific rotation with a particular concentration. Then repeat the experiment for the different concentration of the sugar solution. Then we find out the effect of solution concentration. Then we can also take the reading on the room temperature as well as we take the other different temperature also. In this experiment, we can find out the effect of temperature, effect of concentration, effect of the length of the tube. Now this is the schematic diagram. Here we see light source, lens is used. After that, polarizer we are using, that is a nickel prism and denoted by N1. Half shade or bi-quartz devices used, but here we are using the Lorentz half shade. This is made of quartz as well as glass. The quartz must be having, it is cut from the optic axis, the phase change of pi and the path change of lambda by 2 introduced between the ordinary and extraordinary light. It means the light from the polarizer is the polarized light. It passed from the half shade, Lorentz half shade plate, and it again divided into ordinary and extraordinary light. And then there is a change in the velocity. Ordinary light move with the higher velocity as compared to the extraordinary light. The light, the output passed from the polarimeter. You see the shape of the polarimeter. Here there is a change on the side of the polarimeter. Why we are having these bumps in the polarimeter? Why it is tilted here? Because the bubbles may be avoided in the path of the light, and light pass from this tube, from the solution, then the rotation of the light will takes place. That will be noticed through the analyzer and eyepiece. That analyzer contains the eyepiece. We can rotate the analyzer so that we can get a particular angle, or either we are having the brighter part, then we can get change in the direction of polarized light. What we observe generally? We observe the reading. First we take the room temperature, that is 25 degrees centigrade, weight of the sugar we take, concentration we will prepare, that particularly we will use, least count of the analyzer we will calculate, then length of polarimeter, sometimes we take the 10 centimeter, 11.5 centimeter, and then we use the water. Analyzer reading we calculate for the clockwise and for the anti-clockwise rotation we find out. Then this is the table For first we prepare the table for the water solution, because we are not adding any type of solution compound in it. So first we take the pure water reading, and then analyzer reading we will take on the clockwise and then the anti-clockwise direction we take the 3 sets, then we take the mean of that. Temperature will be the same throughout the experiment. The clockwise main reading and the vernier scale reading, total reading we will find out. Anti-clockwise main scale or vernier scale reading we will take for the first position and for the second position. Similarly here, when the sugar solution concentration we prepare and we take the sugar solution in place of the water. So this is the this is the reading through the analyzer, clockwise and anti-clockwise for the first position and clockwise and anti-clockwise for the another position. As we all know, the total reading is the main scale reading plus the vernier scale reading. We will find out the mean in both the cases also. Now for the first position we calculate the theta 1, that is C minus A. We can have the some notations. For the position 2, again we are having a theta 2, that is D minus B. Thus the mean we can take theta is equal to theta 1 plus theta 2 divided by 2. In this manner we can find out the value of theta. Then the specific rotation of the cane sugar solution, we will put all the value of theta, L, C, and then we can find out the S, that is the optical rotation. And the results we can put these values: temperature, specific rotation, standard value of specific rotation of the cane sugar, then we can find out the percentage error regarding this. And the precautions, the polarimeter should be well cleaned. There should not be a bubble in the path of the light passed from the polarimeter tube. Water use should be dust free. Whenever a solution is changed, rinse the tube with the new solution. There should be no air bubble inside the tube, so that the path of the light should be clear. The position of the analyzer should be accurately defined. The temperature and wavelength of light should be stated, at what temperature we are using, and the light, sodium light we are using. Continuous light should fall upon a octave active material, so that the analyzer can detect properly, and the bright light we can get. Reading should be taken when the halves of the field of view becomes equally illuminated. Reading should be taken clearly for both the sets. Now, what are the application of this experiment? This experiment is used to identify the isomer present in the samples, maybe dextro or levo. Dextro means when it is the direction of polarization rotating in the right direction, that is dextro. If it is, that is represented by plus sign. A levo when it is moving in the anti-clockwise direction or in the left hand side, then this is a levo, and then represented by the minus. It can also be used to measure the optical active substances of resin mixture, light indicating the equal 1:1 mixture of the dextro and the levo isomers. Moreover, we can find out the concentration and purity of the solution which we are using. Concentration and purity measurement especially important to determine product or the quality in the food and beverages. Pharmaceutical industries also use this polarimeter experiment to find out the various properties. In the application, we find the identification, determination of the optical active compound. Optical activity is only the one of the parameter distinction between the different type of isomer forms. In the chemical industry, we also use this experiment which find out the specific rotation as a unique property like refractive index in many cases, which can be used to distinguish the different chemicals or materials. Food, beverages and the pharmaceutical industries, concentration and purity is the main criteria, so that we can measure through this experiment. Most of the antibiotics, narcotics, vitamins, and these the concentration or the purity we can find out by using polarimeter. In the sugar industry, polarimeter are used to determine the quality of both the juice and the sugar cane that will be used to find out the further processing. And the polarimeter thin film surfaces is known as the ellipsometry. if polarimeter of the thin films and surfaces is commonly known as a ellipsometry. Polarimeter is used in remote sensing also, and that is planetary sciences, whether radars use this polarimeter. Polarimeter can be used to measure the various optical properties of the material, including the linear birefringence, circular birefringence, and known as the optical rotation, optical rotatory dispersion, and many more applications. We have this polarimeter. We can determine the purity of the particular solution, not only the sugar, but there are the other antibiotics, dextrose, steroids, that we can measure, vitamins we can measure through this polarimeter. We can find out the other chemicals present in the material, then that we also find out by using this experiment. Now there are some viva voice question that can be asked after the experiment. Are the light waves of transverse nature? Yes, we can say that that light waves are transverse in nature. Polarization experiments support this belief. Do you believe electromagnetic waves are light waves? Yes, that can be defined by this. We can get the polarized light, means we are having a transfer as well as a longitudinal waves. Light components plays a role in light, electric field components. Moreover, can we observe the polarized light through the sound wave? No, that is, sound waves are different from the only the optical light. Through optical waves are used to get the polarized light only. No, they have the, because the sound wave they have longitudinal, no transverse component. What is the difference between the polarized light and the ordinary light? That is a basic question generally asked. Polarized light has a transverse component E vector in a specific direction, while the ordinary light vibrates in all the direction. That is a unpolarized, that is a polarized. What do you mean by the plane of polarization? A imaginary plane that is parallel to the electric vector component or the vibrations is known as the plane of vibration. A secondary imaginary plane that is perpendicular, it is known as the plane of polarization. And what is polarides? Polarides basically used which convert the unpolarized light into the polarized light, that behaves as a polarizer as well as the analyzer. Another, what is a Nicol prism? Nicol prism made of the calcite crystal in such a way which convert the unpolarized light, ordinary light, into the polarized light, and that is designed by the William Nicol in 1828. What is the use of this Nicol prism? It converts the polarized light through which plane polarization light is obtained, and it is used as a polarizer as well as a analyzer. Polarizer which polarize the light, analyzer which detect the plane polarized light. So this question can be asked: what is the function of polarizer? What is the function of analyzer? Polarizer which polarize the light, analyzer which detect the plane polarized light. In this manner we can have many questions. Similarly, by using this formula we can solve and we can find out the concentration. As on the screen we are having a 20 gram of cane sugar is dissolved in the water to make the 50 cc of the solution. A 20 centimeter length tube we are using, and in this manner we can calculate the specific rotation. S is equal to 10 into theta divided by LC. The specific rotation we are getting 66.25 degrees centimeter cube divided by gram centimeter. Now, what is meant by optically active substances? Optically active substances is a very important question. Substances that rotate the plane of polarization are said to be optically active substances, and the phenomena is known as the optical activity and the rotatory polarization. So, for now we end this lecture. Thank you very much.